This is an example of solving triangles using the law of sines and the law of cosines. What do we have here is a network of something measured and something which is not measured. So we have here the given quantities. We have line EC for 440. We have the line ED as 470. This one. The angle between them is 60 degrees, which is CED. And we have the angle 97, which is ACE. This angle, as you can see, this is 97, 17 and 42 seconds. We have this angle, which is BDA, also as 87 degrees, and already this one is 97. Now, what is required from this problem is that we have to find this AB, we have to find BD, we have to find AD, we have to find AC, then we find BC, then we want to find also the line CD. Of course, you can pause this video and look at the problem, try to figure out what is given, what is not given, the configuration of the network, and after that we start with the solution. Let's pause. We erased all the scratches. Now we want to start the solution. First, if we take a look at the this triangle, which is ECD. So we start from E, going to C, going to D, back to point E. If you look at this triangle, we have one side given and another side given, and then the angle between them. This is a perfect application for the law of cosines. So law of cosines, we will use it to find CD. I'm here in Excel, and I have some functions to do that. I wrote these functions. So if we consider ECD triangle, I'm always referring to the triangles in a clockwise order, while for the angles I'm referring them to counterclockwise order. So for this triangle we have CED, this is the angle of 60 degrees. I'm putting it here. So I'm preparing for every triangle, I'm preparing the inputs and whatever we want to calculate, and then we have leg EC, and which is 440, and then the leg ED, and this is 470. So all what we have to do is to apply the law of cosines, which is CD, line CD, this one. Let's change the color. So this line equals leg 1, which is A, let's say A squared plus B squared, minus 2 for A, B, multiplied by cosine the angle between them. So applying this will give me an answer of CD equals 456.987. So this is the first triangle that we considered, and we solved this triangle. Let's erase and then continue with the other triangles. So now we have we erase everything. We will come to the next triangle, which is triangle EBD. So this is E going to all the way to B, and then coming back to D. What do we have here in this triangle? We have, this is unknown, this side is unknown. This side, the whole side here, is also an unknown, but we have one side which is known. This angle is unknown, but still can be calculated. The whole thing is here is 180 degrees, and this angle is 87.20. So we can calculate this angle, which we refer to as EDB. If we come to this here, EDB is equal to 180 minus the 87. So this one would be, as shown here, it is EDB, it is 92 degrees. So this is 92, etc. Now, we have this we have this angle, we have this angle, and in this triangle we still can find the third triangle from the summation of the angles. So this one, if we take 180 minus 92 minus the 60 here, so this will give us the angle DBE, this angle here to be as 27 degrees 14 and something. So finding this angle, we have this triangle with 3 known angles and 1 known side. If we apply the law of sines, this is a perfect application for the law of sines. The law of sines will say this 470 over the sine of the opposite angle, which is 2714, and then we have this angle, which is 60, and the opposite side is this one, which is BD. So if we apply the law of cosines, B line BD will be immediately calculated, knowing that we have 470 as the ED distance. Now we can from the same triangle we can find the length of BE, the whole thing, by this is the angle which is opposite to it, 92, 39, 36, and we can use also the same one, this one 470 with the 27, 14. These are, so 470 over 27 will the ratio will equal to the length BE divided by the sine of the angle of 92. So we can now, in this case, we can calculate BE as the length of BD as 1000 to 26,751. But here we do not need the BC. We need the line BC. So BC equals 1000. This one 1000 for the length of BE minus the given length of 440. So the answer is 586. So now we will take another triangle. Let's erase and come to the triangles. After every time we find a length of a line, I will mark it by this tan color. Now let's consider the triangle AEC. Here it is in the red. And notice that I marked the tan color for the known quantity that we just calculated. Now we consider this triangle. In this triangle, first of all, we have 60 degrees as this angle. The other angle, which is angle ACE, it is 97 here. So we have this angle, we have this angle. The same thing, 180 minus 97 plus 60, we will calculate this angle, which is EAC. This angle will be 22 degrees, etc. Okay, so we have 3 angles and we have one line, one known line. So from the law of sines, 440 divided by sine 22 will equal to this side, which is side AE, divided by sine the angle 97. This will give me AE to be 1100. Then we can apply the same sign, which is sine law. 440 over sine 22 will equal to the unknown length of AC over sine the angle opposite side angle 6006, and this will give me AC as 994. So now I have these two lines, but what I need also is the line AD. AD, it is the length of this section of the line. The whole line, we just got it as AE here. So we will take out from it is the unknown length of 470 between E and D, and this will leave us with the line AD. So line AD equals 1000 minus the 470, we know it before, and this will give me 666.891. Let's pause, clean up, and mark the new found lines as the tan color, and then we will continue for the rest of the unknowns. Now we want to find the length of line AB. Line AB, it's part of the bigger triangle, which is A going all the way to point E, going back to point B. So AEB, this is the triangle that we want to consider. Before we found this length, which is AE, and we found the length of BE from previous triangles. This is the BE here, and we found also the AE. So we have one side and the angle between them here, this angle and this one. This is an application for the law of cosines. Law of cosines, which is side 1 square plus side 2 square minus 2 multiplied by side 1, side 2 multiplied by cosine, the angle between them. This will give me this this side, and if we scroll down, it will be 1087.39 using EA, EB, and the angle between them, which is BEA, it's 60 degrees. And here we conclude the solution of this problem. All what we did is just see which triangle you can use, which one is triangle you can start with, and determine what is given. Based on that, you can choose the law of sines and law of cosines. Always find the angles, whatever easy to find. You go ahead and find it and continue the solution. See you in the second video.